A door is either open or closed. A coin lands on heads or tails. A car is either moving or parked. In our everyday world, things choose a state and stick to it, but at the smallest level of reality, nature refuses to pick just one. Welcome to quantum physics. Quantum physics is the science of that refusal. The study of a world where particles can exist in multiple states at once, where observing something can change what it does, and where probability quietly replaces certainty. It's the field that explores how the tiniest building blocks of the universe actually behave. And once you understand even a small part of it, reality stops feeling quite so solid. Quantum physics is the branch of science that studies extremely tiny things, smaller than atoms. We're talking about particles like electrons and photons. These are the basic pieces that make up everything in the universe. In our everyday world, objects follow clear rules. A ball rolls forward, a glass falls down, a light switch turns on a lamp. Cause and effect make sense. But in the quantum world, the rules completely change. Now here's where things start to get strange. Imagine throwing a tiny particle at a wall with two small openings in it. You'd expect it to go through one opening or the other, right? That's what normal objects do. But when scientists performed this experiment, known as the double-slit experiment, instead of behaving like a tiny solid particle, it behaved like a wave. It passed through both openings at the same time and created a ripple-like pattern on the other side. The particle didn't choose one path, it acted like it went through both. And here's the part that really messes with your head. When scientists tried to observe which opening it went through, the particle suddenly stopped acting like a wave and behaved like a normal particle again. It's almost as if the act of watching it changed what it did. This is called the observer effect. At the quantum level, measuring something can actually affect its outcome. Now let's talk about another idea that sounds impossible. In quantum physics, particles can exist in multiple states at the same time. This is called superposition. Think of flipping a coin. In normal life, it lands on heads or tails, but in the quantum world, it can be both heads and tails at the same time until you look at it. The moment you check, it chooses one. Before measurement, it exists as a set of possibilities. After measurement, one possibility becomes reality. It means that at very small scales, nature works on probability instead of certainty. Even scientists were shocked by this. In fact, the famous physicist Albert Einstein had trouble accepting some of these ideas. He believed the universe should follow clear, predictable laws, but experiments kept proving that quantum behavior was real. But why does any of this matter? Because it's the reason modern technology exists. Transistors, the tiny switches inside your phone and computer, only work because we understand quantum behavior. Lasers, MRI machines, solar panels, and even the internet rely on principles discovered through quantum research. And now, quantum computing is pushing things even further. Unlike regular computers that use bits, zeros, and ones, quantum computers use quantum bits or qubits, which can exist in multiple states at once. This allows them to process certain types of information incredibly fast. We're still at the early stages, but the potential is enormous. The deeper message of quantum physics about perspective, it shows us that reality is far more mysterious than it appears. The solid world we experience every day is built on a foundation of probabilities, invisible waves, and strange connections that stretch across space. At large scales like planets, stars, and people, everything averages out and behaves normally. That's why we don't see these weird effects in daily life. But underneath it all, the universe is operating in ways that challenge our intuition. And maybe that's the most beautiful part. Quantum physics reminds us that we don't know everything, that the universe still holds secrets, that the deeper we look, the more surprising it becomes.